I built an alarm that wakes you up using artificial light. Morning sunlight is especially important because it helps regulate your circadian clock. While artificial light does not completely replace natural sunlight, it is a great way to start your morning and much less intrusive than conventional alarms. In fact, it also works on cloudy days, which has been a struggle for me as a person in Vancouver. The goal of this project is to build a sunrise alarm for cheaper than if I would have bought it. Let's get into it. I first hopped on to ChatGPT for some inspirations. And yes, I did do some research. I eventually settled on this WS2812 24 LED ring, a power-only USB breakout board, this DS3231 clock module for time tracking, and a beautiful acrylic globe. After a couple days, my packages have finally arrived. Let's take some time to appreciate this beautiful package by DigiKey. Now, when I was fiddling with the newly arrived items, I came into the realization that the LED ring does not fit. The manufacturer clearly claims a 3.74-inch socket diameter, while the outer diameter of the ring is 3.3, so I figured it must fit, right? Nope. Two hours of my life gone. Anyways, I got the inner diameter to 3.44 inches. Perfect. Next, aesthetics. I want this product to look minimalistic. I want the base to be able to have a display. And after countless terrible drawing sketches, and yes, I am not good at designing, I did a right thing. Ask for help. After some help from my very kind sister, we decided on using a trapezoidal prism as the base, which is not only minimalistic, but also allows me to mount the display very easily. So I quickly 3D modeled this idea on Fusion 360. Printed out the base, hooked up some wire, and I think it looks pretty nice. Aesthetics aside, my idea was to connect the globe with a potentiometer, so that turning the globe is the way that the user interfaces with the product and selects the time they would like to wake up. First up is the DS3231 clock module. I quickly hooked it up with some wire on the ESP32 room, which I will be using for this project. And then I realized that I put in the battery the wrong way, so I quickly flipped it. And I adjusted the time by about 40 seconds. For the display, I played around with some that I could find laying around. I didn't really like this 1602 LCD display because of the blue backlight and 2 lines of text. I didn't like the high resolution LCD displays either. So I eventually settled in with this 4-digit 7-segment display, which I think is very minimalistic. Personally, this was the best looking one I could find. I was also thinking about e-ink paper displays, but I eventually gave up because of the price. Let me know if there's any better alternatives. Before I could forget, I 3D modeled the rest of the base, which includes the opening for the display, the opening for the USB-C charging port and for a switch on and off, and the sliding rails for the globe. Once the testing was complete, I hand-drawn this wiring diagram because I wanted to. Enjoy this time lapse of me putting the components together for a breadboard prototype. This turned out perfectly. I could adjust the time from turning the knob of the potentiometer, select that time by pressing the button, and the time display was accurate. I then moved on to soldering everything together. Now, once I plug in the USB-C port and click the button to turn the item on, the turning of the potentiometer allows me to adjust the value from a range. This can then be easily repurposed for setting an alarm. My next issue was turning the globe. Essentially, I want to run an axle from the potentiometer to the top of the globe so that turning the globe turns the potentiometer along with it. The globe would rest on the trail. The problem is that when I try to turn it like this, there's too much friction between the globe and the trail, and the base is not heavy enough, so the entire base moves. I tried to add some furniture pads to increase friction. It didn't work. There are two ways I can go about this. One is to increase the length of the rod so that the entire globe rests on top of it. As a result, there is not going to be any friction between the globe and the trail. The second idea is to add one of those sliding rings, like those you see in microwaves, to make the turning more smooth and more concrete. For now, I just simply connected the globe with the potentiometer. This is the result. Overall, this project was a success. The budget was just a little bit under $50. And the aesthetics are pretty nice as well. There are a few things to be improved. This includes the acrylic globe, which has a cheap feel to it. And finally, the LED ring that I used was simply not quite enough. A speaker perhaps could also be added to make the alarm more effective. Please let me know your suggestions down in the comments. And please subscribe before it's time to wake up. Thank you so much for watching. Have a great one.